Okay, let's start. Привет, everyone. Nice to see you all. There are a few more people just sneaking in. Yes, please sit. Before we start, just a quick check on how many people here are involved in mobile test automation. Please raise your hand. Or even if you have done it in past. Okay, and how many of you are using Appium? Quite a few. And how many of you are using Calabash? 2, 3, 4, very few. And what are the other possibilities? How many of you are using native frameworks like Espresso, Android, UiAutomator? Yes. Thanks for the answers. As you might have sensed, I spoke only about the Android-related things. So this talk is going to be very specific about Android automation, and it's going to be about a case study which we faced at Badu about our Android automation and a problem which we faced and how we solved it. So this talk has no iOS-related stuffs in it. But I'm happy to discuss about how our iOS stuffs work after my talk during the discussion zone, maybe. So welcome, everyone. My name is Rajdeep. I work at Badu. It's been 8 years into testing. Even I can't believe it myself. So I'm passionate about automation. I'm mostly involved with mobile automation, and my area of focus currently is Android. And this is going to be the agenda of today's talk. I'll talk about why we started with Calabash. There's only one person who is new, I know, that is using Calabash. So it's not very popular, but why we started it. And then I'll talk about why people are running away from Calabash, one of the big limitations of the Calabash, and the solution. I'll talk about how we solved that problem. And I'll also speak a bit about our future with Calabash. So those who do not know about Badu, Badu is one of the biggest social dating application. We have like 360 million registered users. That's probably more than the population of United Kingdom and Russia combined. So it's very huge. We have got 47 languages in which our application is translated. And we have got 2 offices, one in London, one here at Moscow. And we have almost 350, or more than 350 people, and we always look for new talent. So in Badu, we have 3 platforms: Android, iOS, mobile web, and actually we have a desktop web component also. I work mostly with the Android team, and I'm responsible for Android test automation. And these are the tool sets which we use for a very typical one. We use Ruby as our, some people hate Ruby here. I know one of them, definitely. Then we use Android. We use Cucumber as our BDD framework. And as for Android driver, we use. So our story started with Calabash almost 5 years ago when we were looking for some cross-platform testing tool. So we wanted to do automation for Android and iOS and mobile web in one framework, and hopefully same tool for Android and iOS automation. So at that time, the choices were very limited. Appium was still very new back then, and the only thing which worked very nicely without any flaw was the Calabash, and we chose Calabash then. And the problem is, whenever we choose some tool, it might work initially very well. We like it, but as and when the new business requirement gets added, newer operating systems of the platforms get released, new limitation of the tools starts to surface. And whether it be any tool like Calabash, Appium, or any other native framework we are using, after some improvement in the framework. And something similar happened with us. So far we have been very happy with Calabash. We got almost, actually more than 1,000 tests, and they are very stable, very fast, and fast in sense compared to Appium. There's a reason for it. I'll talk about it in the later slides. And we have done some really cool stuff with Calabash, which is otherwise not possible with other contemporary black box testing tools, like integrating Java code coverage. So with our functional tests, we get Java code, our code coverage of the application. We also do some analytics testing. So whenever our user do some actions on our application, we send some data to our analytics server, and we validate that data using the Calabash. I'll talk about how we do it. So it has been really good. We are able to do some things which is otherwise not possible. And if you are more interested in how we do code coverage, there's a really nice blog post written by one of my colleagues, and it's available on our website, tech blog. So, and there is some more thing which we are doing. I'll talk about it in the later slides. But so far it's been really good. But there's a major limitation of Calabash. There are some really important things which we have not been able to do. Can anyone guess what is it with Calabash? I know one person who has used Calabash. What we cannot do with Calabash? Yeah, exactly. It's not just push notification. So Calabash has a limitation of app-only testing. So if you are testing some app, you cannot interact with any other component of the Android which is not part of your app. For example, push notifications. We cannot expand notification bar because it belongs to Android system, not to our application. So this is one of the very important features for Badoo, because we engage our users based on push notifications. We are a social dating app, and if someone likes you, someone makes you a favorite, we want users to be notified very early, and we want to basically want to have more activity in our app using push notifications. And we cannot test it, and that's very sad. There's one more example we want to share. We encourage our users to share the profiles they like with their friends. And it's very easy to do. You just tap on the share button. Android operating system gives you a resolver activity with possible actions. Like you can share it with WhatsApp, Google, or any third-party app. But this does not belong to our app, so we cannot interact with this. And worst of all, there are really important features which we could not automate, and one of them was payments, money, right? So this dialog, if you see, where we have the button buy, it does not belong to our application. It belongs to the Google Play application. And Calabash cannot do cross-app testing. So we cannot automate the payments. So one of the possible solutions, there are many possible solutions, but keeping in mind of our functional test, we want to have a single framework for all the platform, and we do not want to change our language. We want to keep, because it will be a big movement. So while using Ruby, there's one possible option is to change our underlying driver to Appium, because Appium can do cross-app UI testing. There are two options. We can change Calabash, replace Calabash with Appium, or we can add Appium in addition to Calabash. But there are some problems with adding Appium and Calabash together. They fight for the control of the application. If Appium starts the app, it kills the Calabash instrumentation. So there's some work need to be done there. Migrating to Appium could be easier, but we are already using Appium for one of our another app. So whenever we get chance, whenever we have new application, we keep trying different tool sets at Badoo. So we have been using Badoo, and we have been using Appium at Badoo for one of our application. And the experience so far has not been really great. It's slow. And it doesn't have one of the very important features which actually Calabash have. It's a very powerful feature called Calabash Backdoors. How many of you here were there for this scaling Selenium talk? Definitely, Simon was here. So only a few. But there was very important point which Simon talked about. It was let your app do the hard job of determining the state or anything else. So it's kind of similar philosophy here. Backdoors are basically methods defined in your application which you can call from your test code, right? Let's look at it with a very simple example. So for example, you have an Android application which has an activity, let's say login activity. What you can do is you can define a method in this activity class, let's say foo, and this method, you can tell your application to do anything which helps you do testing. For example, you can set some database state. You can disable some random pop-ups like give me feedback. Or maybe you can set some app state or change URL, or whatever you want which helps you do testing in a predictable manner. So if you define this method, you can very easily call it from your Ruby code, which is test automation code, by simply using the backdoor API. You say backdoor and the method name as a string. It's a very simple example, but you can create complex backdoors which returns you value as a parameter. The way it works is using reflection APIs. So this foo string gets passed to Calabash server, which is actually instrumenting your app under test. And this string, using the reflection APIs, it actually calls the method inside your application, which is very powerful feature. Someone called it cheating in Simon's talk. So it's like it's very cool feature. Like you can do whatever you want, gives you the tremendous power, right? And we use this feature a lot at Badoo. Some of the examples are we change app locales. As I said, we have 46 different languages in Badoo, and we want to be very quick in changing languages. We have developed different tools which capture screenshots in various languages, and we do it very fast using the backdoors. We change API URLs, like we create only single artifact, single APK file from our build system, and whenever we want to run tests against staging or system integration or production, we change URL using backdoors. Getting some data from app like session ID. If you want to get session ID of the logged in user from the app, we do. I know many people do it during their Selenium test, and then they use this session ID to call their backend API to do some stuff like disabling CAPTCHA or something. So we do this similar thing for our mobile tests. Disabling some repeated features. So like almost everyone, all apps have this what's new or onboarding things. You have to click next, 3-4 times to actually land on the real page which you want to do testing. You begin testing from. So we disable these repeated things for all of our 1,000 tests using backdoors. There are more things which we do, like disabling some A/B test or setting some A/B test variant to make our test more predictable. Faking some payments related parameters, like we can fake. We have a Vodafone SIM in Germany, and now we make payment, and we see these are the payment options on the UI. So it makes life very easy. And getting analytics data from the app, which helps us validate our analytics data. That's what I mentioned about analytics testing. So the whole point is backdoor builds testability inside the app. It makes your life very, very easy. You offload the heavy lifting to your app, and you just validate what you want. And Appium does not have this. So although Appium can do cross-app UI testing, but if we move to Appium, we lose the power of backdoors, and we do not want to lose it. So this movement to Appium doesn't sound really good. But there's always a curiosity, like why it works, why this works, why that doesn't work. So let's see why Appium is able to do cross-app UI testing. So those who are using Appium might already know about this architecture, but I'm not going to get into deep of this diagram because this is not an Appium related talk, but I'm happy to talk about this during discussion zone. So after following the JSON wire protocol, request goes to request handler, and then there's a executor handler which handles the request and gives it to underlying driver, which is actually Google's UiAutomator2 driver. And that's actually the driver which is suitable for cross-app testing. So this is the piece, this is the bit in Appium which makes it eligible to drive cross-application testing. Now, why can't Calabash do it? Because if you look at the Calabash, it's based on a driver called Robotium at the very bottom. And this driver is based on instrumentation, Android instrumentation. So the way Calabash works is there is a Ruby client which sends the request to a HTTP server, which is in fact an APK. So the dotted lines which you see is actually packaged in an APK, which instruments your app under tests. So there's a HTTP server in this APK, which listens for the command, passes it to the command executor, and the command executor gives it to the Robotium driver, which in terms drive the UI. Now, this instrumentation is the piece which is actually enabling the Calabash to drive user interface and also to do the backdoors to call the application methods, because this knows about the context of the application. So this instrumentation is actually Android's testing support library. Many of you actually raised your hand for Espresso. So actually, Espresso, if you know, it's also based on the instrumentation. So it's one of the popular frameworks these days. Robotium is also based on instrumentation. And the instrumentation actually runs in the application's context. So if you are testing some app, you instrument it. So this instrumentation knows all the data about your app. That's what enables the backdoor in Calabash. Instrumentation exposes all the interaction that the app has with Android system, and that's why instrumentation is able to drive your application under test. And the UiAutomator2, which is used by Appium, is now based on instrumentation. So it happened last year that the Google changed the way UiAutomator worked. Earlier it was it used to work in a standalone jar, but now Google changed it to now it's based on the instrumentation-based API. And now that rings the bell. If it's based on instrumentation API, Calabash instruments our application under test. Why can't we do this? So we already saw this diagram. We have a Robotium driver which utilizes the instrumentation data to drive our app. Now what if we insert a UiAutomator2 layer below the instrumentation layer? If we can do this, we can basically drive the whole device. We can do cross-app UI testing. And that's what we went for. So we chose to modify the Calabash server in such a way that we use the same instrumentation info, which is used by Robotium, and we create a UiAutomator instance to drive the cross-app, to automate the cross-app cases. And that's the right way, because we don't need to modify our tests in any way, right? So the next few slides are going to be about how we mixed Calabash with UiAutomator. By the way, if someone is curious, many of people are using Appium, and I told that Appium uses UiAutomator. UiAutomator has instrumentation-based APIs. So why doesn't Appium has backdoors? Like, if you are very curious, let's talk about it during the discussion zone. So there are some things which we need to do this, mixing the UiAutomator in Calabash. We need to first clone the repo, extract the UiAutomator2 binary from the Android archive. It's hidden somewhere in the SDK folder, and add it as a dependency in our project. And then let's get started with the actual part of how can we mix it. So those who know about instrumentations, a few people are using Espresso already. Some people are using UiAutomator. But the entry point to instrumentation is a ADB command, ADB shell AM instrument. And this takes two parameters, the test class name, test package name, And the second parameter is the name of the instrumentation test runner. In the usual cases for Espresso or UiAutomator, is the default JUnit for runner. But Calabash has got its own instrumentation runner called Calabash Instrumentation. And this is how it actually looks. So Calabash Instrumentation extends the Android base instrumentation class. And this is the class which gets instantiated before anything happens, before even your actual code for your application gets instantiated or initialized. And in this class, there is a method called onCreate, which Calabash overrides. And this is the method which gets executed very first. So when we say ADB shell AM instrument and the instrumentation test runner name, this onCreate is the method which gets fired up. So it's like the entry point. And Calabash uses this as their entry point. They do two important things. One is store the instrumentation object in some utility class. And second is start a HTTP server, which starts listening for the command, hangs there, just listens the command, passes it to Robotium, and drives the user interface. So we are going to look at how we can enhance this Calabash instrumentation. So there's a class called instrumentation backend, which is the utility class which I spoke, which holds the instrumentation object. So there's a static field called instrumentation, which is actually the instrumentation object. There's a field called solo, which is the Robotium driver. So in the Robotium binary, the driver is called solo. And this is the object which actually drives this has the APIs to touch, click, drag, and all these things. But it can do only in-app, like only the application level testing, only our application. So let's do one thing. We create something similar to solo but with UiAutomator2. So let's create a instance of UI device. Now this UI device is a class which is defined in the UiAutomator2 library. We define a simple instance of UI device, and we create a getter for it. So it's very similar to how it's already done for Robotium. We're just doing the same thing for UiAutomator. It's again static field just to be compatible with existing code. So we define a get UI device method and simply get an instance by using the existing instrumentation object, which we stored in a utility class. The code is not really fancy. It's very simple. You say UI device equal to get instance using the instrumentation. And this method, you get UI device, we will be using for all our purpose for driving the whole. Automator APIs are very rich. So let's implement something which we could not do earlier, which is expand notification. And it's a very simple example. You will see how simple is it to do with UiAutomator. So this is what we are going to do. We are going to create a simple class, pull notification. We are going to implement the action interface, which basically defines what we want to do with this class. And then we'll give it a unique name so that we can call it from our Ruby client. Let's get started. We created a class pull notification, which implements action. Now the action is the interface which is implemented for all the commands for Robotium, like click, touch. And this is the action which is, so all the commands used in Ruby code basically are mapped to this interface. So when we call click in our client-side code, they call some click action on the server side. So this method, this interface declares two methods, and we need to implement them. One of them is execute, in which we need to tell what we actually want to do. And in the pull notification class, we want to do a very simple thing, which is open notification. And the code here is really very simple. We get UI device, which we defined in the previous previous slide, and then use the rich APIs of UiAutomator2, which is like open notification, and we are done. Next thing is we have to give it a name as a key, and we need to override key method, and let's call this method as this key name as pull notification. So if we define this, and this pull notification as a string key will be used from our Ruby code with a very generic API called perform action. So this is how we will call this. Perform action, which is very generic API, which accepts the key name of the action. Say perform action and pull notification. And that's pretty much it. It's very simple. Now, the example which I gave was about pull notification was very simple. It's just one API call, UI device.open notification does it. There are complex actions like touch and multi-touch gestures, which we can implement using UiAutomator2 for driving the whole device. So we have done this, and with this, we have broken a very big limitation of Calabash-Android. And so far, we have implemented actions like find element, touch, expand notification, clear notification bar, dump text. So now we have power of cross-app UI testing and also the backdoors. And we have the tremendous power then. So if you want to look at this code, it's available in our official GitHub repo. So we solved one of the problems, and what's next? So we are, as and when so these are very limited set of actions which we have implemented for cross-app testing. And as and when we need more things, we do it in our repository, which is a fork from the official Calabash Android server. And so what's the next future plan for us? Many of you who are using Calabash or have used in past might already know that there are talks going about it being out of service. It might not be maintained in future Android versions. So that definitely makes us think about what's going to be our future with Calabash. So it might not be maintained or might not be in active development for long. So there might be some breaking changes with the newer operating systems or newer versions of the Android system. And what we will do is, whenever there's any breaking change introduced, we will replace that component of Robotium with UiAutomator2. And we will maintain as long as we are going to use it. So that was it. The whole point was there was a problem, we solved it, and that can happen with anything. Maybe it can happen with Appium also in future. So we should always be ready for, we should always be open for modification. And open source is a very good platform because it allows us to do whatever we want. And yeah, that's pretty much it. Thank you so much.